One second. I was not recording. Okay, now. So whenever we are doing any calculations, okay, here you can see we are having integer function like addition, subtraction, multiplication, division. Here is showing underscore I. Similarly for add t underscore di means here we are having different data types. So when we are performing addition and subtraction, okay, so I can do addition for the same data type. Okay, so your data type should be same. Then only I can perform this calculation. If the data types are different, I cannot do this calculation. Okay, so I need to convert from one format to another format. So for example, I'm using integer function add underscore I. Then I take some memory like MW42 and MW44 here. Okay, so add means what? Adding two numbers. Okay, so for that we are having two inputs, input 1 and input 2. For that I am using some word memory because it is for integer. One integer means 2 bytes or one word. That is a 16-bit value. Right, so MW42. Then next will be MW44. Okay, so we have to check that addressing concept I have shown. Okay, in bit memory addressing. Okay, just remember that addressing concept always. Now, so store that in some another memory, MW46. Let's see this instruction. I can monitor here. Now, so there's some value here in MW42. Say 200 is there, and I'm adding with some under value like 150. So your result is 350, which is stored in MW46. If I want to change the value, select here, right click, modify, like 345 something. Add. Okay, this is the result. Now, if I want to further add this value with double integer memory or subtract anything I want to do, like multiplication, something else. Okay, so for example, I want to do subtraction. If I move this cursor here, you can see it is showing input 1 as d integer, means double integer, but here your output is integer. So these two data types are different. Integer is 16-bit data, whereas double integer is 32-bit data. So what I need to do is I need to upgrade this integer to double integer. For that I am having this converter, integer to double integer. So MW46 is stored in MD48. Then MB48 here, MB52. So here MD48 means 4 bytes, 48, 49, 50 and 51. Double word. So next available byte number is 52, right? So MD52. Similarly, your output will have another double word MD. What's that? 56. So download. Now, so this 3595 is converted to 00003595. Is upgraded from 16-bit value to 32-bit value, right? Now, if I want to subtract with some value, like you can see already some values there, just 5000 is there. So we are getting minus value, minus 1405 left. Okay. If I want to give some other value, like 2000 something. Okay, this is the result. Okay. Now, this is the purpose of using this integer to double integer for converting one data type to another data type. Similarly, if you want to do with real data type. So in integer function, you can see we are having only for integer and double integer. But if I want to do it with real, I should go with the floating point function. Here you can see add underscore r, subtract r, multiplication r. Okay. So I take this add. Now again, if you see, this is your double integer, but for r symbol, it is your real. Okay, so these two data types are different again. So double integer to real. So I need to convert this data type again from di to r. So md 56 to md 60. For real value, it is always double word. Okay, so md 64, then md 68 to md 70. Now download and check in the run. Okay, so it is adding with this value. Okay, sorry, like 64. This converted value memory address where to take md60. md60 is added with this value is added with this 5900 something. We are getting the result. Or I can do like 245.678 something. These are okay. This is 78 means it is taking 68. Okay, 68 only. Okay, so this is the purpose of using these converters. Okay, and other ways like we are having comparator also. In comparator also you can see we are having IDR. Okay, IDR. I means integer, D means double integer, R means real. Means these are also different data types here. Comparator means what? Comparing two values. Okay, means those two values can be equal or less than or greater than to each other, right? So they are less than or greater, right? So if the condition is true or false, depends on the comparator type we are using, like greater than, right? If any value is greater than another value, so the condition will be true. For that, we can make some digital outputs on or off. Okay, so this is some example here. For equal to, we take W76. So when the value is equal to 5, input one is your actual value. Actual value means which is changing, right? Whereas input 2 is your comparing value. When in actual value is changing and when this actual value is becoming equal to your comparing value, okay, so this is equal to double equal to symbol I means integer. Okay, then your output should be on. So I take like 20.0 view. Now, right now in MW76 value is 0, which is equal to 5. No, so the condition is false. False means it is 0. Okay, I can modify this, right click, modify, like I modify to some 3. 3 is equal to 5. No, condition is false, right? Output is off. If I modify this to 5, so okay. No, both are equal. So the output is condition is true, so output is true. On. If I make this 6, again this will become false. Okay, so this is how we can use the comparator. Similarly, we're having not equal to. Not equal to means if I take MW76, same input, and it is not equal to 7. U 0.1. So you can see y is not equal to 7. So condition is true. So output is on. If I modify this to 7, means values becomes equal. Okay. So when it is not equal, then only your output should be on. Right. So, but here the values are equal. So it is off. Are you getting here? Okay. So 8 is not equal to 7. So it is 3. This way, we are having another comparators here, like greater than MW76 is greater than like some 8 something, U 0.3. See, 8 is greater than 8? No, because here we are having condition only for greater than 8. So it should be 9. Okay. So here 8 means false. Okay. So I make it to 9. 9 is greater than 8. Then the condition is true. Your output will be on. Similarly, we are having less than. Okay. If it is less than 8, that means up to 7 only, it will be on. Same way we are having greater than equal to. So MW76 is greater than equal to like 9 or as well 10. To 0.3 something. So if it is 9 also, it is off, right? If I make it 10, it is equal to as well as greater than 10. So it is equal to 10, right? Condition is true. So output is on. If it is greater than 10 also, your output will be on. Okay. So this way you can use these comparators. Okay. Similarly, if you want to use for double integer or real, okay, if I want to compare this integer value, whichever is coming in MW76, then I need to convert it first. Okay. Using converter like integer to double integer. Okay. Then I use this control X. Okay. Convert this to MD 78. Then I can use this compile. So MD 78 to MD 82 or L hash. Direct value you can mention like when it is 10, L hash 10. Okay. L hash means large integer, double integer. Okay. See, we are converting this 11 to double integer, 32-bit value, then we are comparing. So it is greater than 10. 11 is greater than 10. So output is 3. Condition is on. And suppose if I have to compare between the range means like between 10 to 1, I want to make the output on between 3 to 8 something. Okay, so I can use this comparator is in series, that greater than and less than in series. So MW 76 9, which is less than, I want to compare up to less than 8 and greater than 3. Greater than 2 means 3 to 8. Or if you want, you can use greater than equal to and less than equal to also. Directly 3 to 8. Okay, that way also you can connect this comparison series. You can connect this in series or in parallel also. See, 11 is greater than 9. So here it should be less than 9, means up to 8. So this is false. This is true, which is greater than 2. Right? 11 is greater than 2. So output is, this condition is on, but the output is off because this is false. I can change this, modify to like 6 something. The 6 is greater than 2. This is true. 6 is less than 9. This is also true. So your output is on. Okay. So this way I can use these comparators also. Okay, you can compare the values for integer, double integer, and real. Okay. So your data type should be similar for arithmetic functions also. Arithmetic means addition, subtraction, for that calculation also. Okay. This is how we are using this comparator, converters and comparators, addition, subtraction. Okay.